Today we are doing lesson 3.1, simplifying algebraic expressions. Our I can statements, I can use properties of operations to simplify algebraic expressions, and I can solve real-life problems involving expressions. All right, so I want to start by talking a little bit about like terms and unlike terms. Like terms have the same variable, that means the same letter, and the same exponents. Constants, which are numbers without a letter, are also like terms. So there are some examples here of different like terms. 3x and 2x are like terms. The number in the front tells you how many x's you have, but it's the same thing. It's an x and an x. W and w divided by 7, those are like terms. That divided by 7 is kind of like 1/7 of something. So again, regular w's, those are like terms. And then 5 and 1 and 8/10, those are also like terms because they don't have a variable at all. Some examples of unlike terms: 5x squared and 2x are unlike terms because the exponents are different. This one has an exponent of 2. 6a and 6b, the variables are different. The coefficient, the number in the front, is the same. You have 6 of the a's and 6 of the b's, but that's not what's important. The shape, the thing, the variable, that's different. And then 3 and 2/10 and n both have one part to it, but they're still not like terms because one of them is a letter and one of them is a number. So let's start by looking at some expressions with some different shapes. I like to think of our different variables as being different shapes. All right, so let's see. If I was going to write the expression x plus 2y plus 3x, and then I wanted to find our like terms. So let's see, I have 1x, the number in front tells you how many, and if there's not a number in the front, like this one, it doesn't have a coefficient, that means the coefficient is 1. There's 1x. Okay, so I have my 1x, I need 2 y's, and then I need 3 x's. So then I'm looking for like terms. What are things that are the same? Well, my x's are the same. They're the same shape. They're yellow squares, and the letter's the same, x. So if I put my 1x with my 3 x's, that's combining like terms. It's taking the things that are the same shape and putting them together. So if I wanted to write my new simplified expression, I could write it this way: 2y plus 4x. Or I could have put the x's and moved the pictures up here, and I could have written it as 4x plus 2y. Remember, an addition, that is cumulative. We can use the commutative property, so it doesn't matter the order that we write our expression in. Okay, so I'm going to erase what we have here. And I'm going to go ahead and get rid of our pictures too, and then we'll do something else. Okay, so let's say I wanted to write the expression 2x plus 2y plus x squared plus y. Okay, that's my expression that I need to simplify. And simplify with expressions means find and combine the like terms. So I'm going to start by just pulling out the shapes. 2 x's. So I need 2 of these. 2 y's. X squared, and there's not a number in front, so that just means 1. 1x squared. And then 1 more y. Okay, so now I'm looking for my like terms. My x and x squared are similar. They've both got the letter x there, and in my pictures I've got a square and I've got a cube, but they're not the same. That x squared means it's a different shape than our regular x, so we can't combine it. However, we can combine these y's. I have one y here, I have two y's here. So the y's are like terms, and I can combine those. So my simplified expression, whoops, gotta go back to my pen. My simplified expression for this one would be 2x plus 3y plus x squared. Like terms have the same variable and the same exponent. All right, so simplifying expressions. Here are the steps we're going to use. We're going to change subtraction to addition if we see subtraction. We're going to use the commutative property and the associative property to move and group the like terms. And then our last step will be to add like terms. So those are the steps we're going to be using today. All right, so 14a minus 5a. Now on this one, I have enough to take away, so I don't really have to do boom boom, but sometimes people just feel more comfortable always changing the subtraction to addition, so we'll go ahead and do that. Boom boom. 14a plus a negative 5a. So my a's are the thing. That's not going to change. I'm looking at the numbers in the front. I'm thinking 14 plus negative 5. Different signs, find the difference. 14 minus 5 is 9. A. So if I had 14 A's and I took away 5, I'm left with 9 A's. The letter tells you the shape of the thing. The number tells you how many you have. All right, let's take a look at this next one. 9x plus 3y minus 2x plus 5. So I'm going to start by doing some boom booms. Boom, change to addition. Boom, change the sign. Okay, now I'm going to need to use some properties. I didn't need to use any properties on that last one because I only had two terms to combine. I see like terms 9x and negative 2x. I need to put them next to each other. I'm going to use my commutative property. 9x plus negative 2x plus 3y plus 5. Okay, now I don't have to use associative property because these are the first two terms anyway, but I like to use associative property combining like terms. I just think it makes it easier to see what you have to do. All right, so for 9x plus negative 2x, different signs, find the difference. Notice how that minus sign traveled with that 2x. That was a plus negative 2x. I needed to take that minus sign with it. Different signs, find the difference. 9 minus 2, or 9 plus negative 2, same thing. That's going to be 7. So I have 7 x's. I don't have like terms over here, so I can't do anything with those terms besides rewrite them. 7x plus 3y plus 5. The terms are the things that are in between the plus or minus signs. That's what a term is. Okay, and then our last one here, I have 5d plus 3f minus d plus 2f squared. So boom, change to addition. Boom, change the sign. All right, so I have now a 5d and a negative d that are like terms, and I have a 3f and a 2f squared. And again, if it helps, you can always circle the sign in front of the term, and then you just have to make sure that you move that with your term. So both of my f squares have a plus sign in front of them, they're positive. And my d had a minus sign, which has now become a plus negative. All right, so now I'm going to use my commutative property. I'm going to reorder them. 5d plus negative d plus 3f plus 2f squared. I'm going to go ahead and put parentheses around my like terms. This is a 3f and this is a 2f squared. Different exponents, they're not like terms. 5d plus negative d. If you want to think of it as -1, some people like to actually write in the 1 so they can see it. Feel free to do that. 5 plus -1 is 4. Different signs, find the difference. So I have 4 d's, and then I have 3 f's, and then I have 2 f squareds. That's my simplified expression. Okay, let's look at this next one. Write and simplify an expression for the perimeter. So if you think back to 6th grade when you did perimeter, perimeter means you're adding the sides together. So that's what we're doing. But instead of seeing numbers, which is how you've seen shapes in the past with numbers for the side length, this time we have letters, we have variables. So we're going to write our expression and then we're going to simplify it. Okay, so I'm going to start by writing 2x plus 3 plus 3x plus 2 plus x. So 2x plus 3, 3x plus 2 plus x, written as one big, long addition problem. Now I'm going to reorder. I'm going to put my x's together. I'm going to put my constants together. 2x plus 3x, I'm using my commutative property here, plus 1x. If you like to see the 1, you can write the 1. You don't have to. Plus 3 plus 2. All right, I'm going to go ahead and put some parentheses around my like terms just so I can see what I have to add. 2x plus 3x, that's 5 x's, plus another 1 is 6x, plus. And then 3 plus 2 is 5. When we have perimeter, most of the time they're going to show you a label like feet or inches. But this one, they didn't give us a label. So we're just going to write units. So 6x plus 5 units is the perimeter. All right. This time we're actually writing in the properties that we used. You've seen ones like this before in both chapters 1 and 2. But it applies in chapter 3 as well. We're still using those addition and multiplication properties. So write the properties next to each step. I have -6/10 y plus 3/10 x plus -1/2 x plus 6/10 y. Okay, so like terms need to be next to each other. So I'm going to do 6/10 y and -6/10 y next to each other. Okay, so that is commutative property. Okay, when I combine those two inverses, that just equals 0. I don't need the y anymore. If I have 0 y's, it's just 0. It's gone. So that's the inverse property, combining those two together. And then I'm adding what I have left, +3/10 plus -5/10. Different signs, find the difference. So that would be 2/10. More negatives, answers negative. So I have -2/10 x is going to be my final answer. All right, same thing. This one has fractions with it, but it's the same idea as doing it with the whole numbers or the decimals. Okay, so first thing I'm doing, I'm looking for the like terms. This has an R, this has an R. We're going to group those together. They're already next to each other, so I don't have to reorder it. I just have to put the parentheses around it. So I have -1/3 R and 1/3 R. That's the associative property when you group with parentheses. Okay, well, -1/3 R plus +1/3 R is 0. I don't need to put 0 R's. If I don't have it, it's just 0. Okay, that's the inverse property. I combine my inverses. Okay, and the -2/5 D plus 0. That 0 I can just ignore, -2/5 D. That's going to be the identity property. A number plus 0 equals itself. So even though this was originally with an R, because they canceled each other out, it's gone. We're just ignoring that part.